College, Dublin, and she'll tell us about root phenotyping in the field.
Hey, thank you very much for the opportunity to speak today. Hopefully the slides will come back. So I'm going to tell you about some of my research at the moment about trying to root phenotype in the field, so using X-ray CT to look at roots in field-structured soils. So before I moved to Dublin, all of my research was pot-based. So we're just moving into more field-structured soils. So just a quick outline, I'll talk about some of the challenges we're facing, how X-ray CT could be the technological solution, and then some of the applications, and then just end with a few of the challenges that still remain, some of the issues that have come up in the research. Just to give you a quick background to Ireland, so agriculture is a really main part of is a sector in the, a huge sector in the economy. Ireland in 2016, we established the National Plant Phenotyping Network, which acts as the node into emphasis, which is a 10-year grant about combining root phenotyping infrastructures across Europe. But the main areas that a lot of Irish plant scientists are interested in is grass and fodder, forestry, horticultural crops. Plant pathology is a really large area in terms of the plant science, our research focus due to our climate, so it's very mild and very wet, and cereal crops and the tillage sector as well. As we've probably heard lots of times, phenotyping is described as a bottleneck. Some of the issues that we're facing really is how do we see roots in soil? Maybe over the years there's been a lack of measuring and looking at roots, and this could be leaving gaps in terms of some of the focus we have to look at and in terms of breeding initiatives. However, we know that roots are inherently difficult to measure. We can't see them because soil is opaque. So potentially there's some knowledge gaps that we're trying to overcome, and we're with the best people here. Just some global challenges to agriculture we're facing. We're seeing that crop yields are stagnant. The current increases in the wheat yield is only 1%, so this is about 28 kilograms per hectare per year. We're facing a future where we're going to have to input less nitrogen, less water, irrigation. We're seeing increases in environmental regulation in terms of when we can apply fertilizers and maybe what plant protection chemicals we can use. And the land that we are expanding onto, if any, is very marginal. So in terms of how productive this land is going to be is questionable. So these are some of the global challenges we're facing. From a more of an Irish perspective, there's a huge livestock sector. Ireland's very good at growing grass. This is our biggest crop that we grow, is grass for fodder, to feed lambs and cows. And this year we've faced two fodder crises. Back in March, when we had unprecedented snowfall we'd not seen for generations. So we left, this is a picture from back then, about March 2018. So we had a winter that was very heavy in terms of snow, which is rare in Ireland because of the mild climate we have from the Gulf Stream. And then we're currently in a drought predicament, which is again very, very rare and not seen for maybe since the 1920s. And we're facing another crisis now because the grass hasn't got enough water to grow. So really balancing the act in terms of being able to grow enough food to feed the animals, and all of the other questions we have around the agricultural industry is some specific challenges. Also, there's a need for farmers need improvements to help with their decision making. Potentially there'll be more regulation around the use of crop rotation and break crops, which is one of my projects I'll talk to you about, and perhaps this will become obligatory. So those challenges are very complex. I like to simplify things and think, where can we really start? So I would argue that potentially soil structure is at the basis of agriculture. I think if you can have a good soil structure, then a lot of these other challenges we're facing hopefully can at least be alleviated by this. So all of my research to date has been looking at how different soil structures, how roots respond to those different soil structures or vice versa. So this will be the follow-on from the theme of most of the applications I'll talk to you about today. So to date, we've had a limitation in some of the root studies in terms of the methods we employ. They're either very disruptive. Potentially they're looking at roots without soil or soil without roots. We know soil's opaque, and after some of the talks we've heard today, we know that soil is very heterogeneous, very dynamic medium in space and time. So being able to capture that in 3D is going to be one of the hopes that we would have. So just for anybody that isn't aware about X-ray CT, just to give you a quick background, the CT scanners that we use are built purposely for research. They were originally developed for the medical field. So inside most X-ray CT scanners that are used for research, you would see these three things. So you'd have an X-ray gun here, the yellow tube, then you'd have a manipulator stage. On this stage here, we've got a glass rod with a soil aggregate stuck on the top, and then a black panel at the far end, that's the detector. That's where all of the imaging data is collected. The stage freely rotates 360 degrees, so that builds up the volume. You take image slices, and then these are reconstructed to give you that 3D volume. And it works by really looking at the density of the samples. So if you're looking at soil, for example, you've got a contrast between soil pores and the solid part of the soil. So this allows you to really look inside the sample and see non-destructively the solid interiors. But you can scan anything. You can scan chocolate bars, 3D printed titanium, plant leaves, anything you want to see inside of non-destructively. So at UCD, I was lucky enough to get money to buy 2 CT scanners. So the first one arrived in March 2017. It was a GE Vitamex scanner. This can scan samples up to a 30 centimetre diameter, and the minimum resolution is about 2 micron. So it's a large vessel that you can fit the soil cores in. The second scanner is the GE Nanotom M. This is an updated version of the Nanotom S. This arrived just a few months ago, and again, it can have quite a large sample diameter, but the resolution can go down to 0.3 of a micron. I should point out, though, that the main trade-off, the main limitation to X-ray CT is this trade-off between achievable resolution and the sample size diameter. So if you want really high resolution, you have to get much smaller in terms of diameter soil cores. This allows you to get them closer to the cores to the X-ray gun, and you can get that higher resolution. So the reason we've got a suite is because we can scan large soil cores and then smaller soil cores as well. If anyone wants to come talk to me about the opportunity to use phenotyping equipment at UCD, we have lots. UCD is the largest collection of Irish and plant scientists in Ireland, so we've got things like drones, LiDAR, harvester with NI capabilities, lots of other bits of kit. So UCD is a member of IPPN, so please come talk to me afterwards. So in terms of the applications, I'm going to run through now. There's not a huge amount of results in my talk, because all of my PhD students, I'm going to quickly run through 5 of their projects. They're all in their first year, so hopefully in 3 years' time they can come and present the results of the projects that are undergoing. So the first project is Shane Brett's PhD, and he's looking at field beans and trying to see why, if we're not getting their yield potential in field beans, is it something to do below ground? So he's using X-ray CT to look at this. This kind of method pathway that we see there, the blue boxes, is the same for all of the projects, really. They'll take soil cores from the field, from field studies. They'll use the X-ray CT for 3D imaging, but then at the end do classic traditional root washing and 2D imaging as well. The reason he's looking at bean crops, or why beans are an increasing crop that's got increasing area in Ireland, is it's a protein-rich crop, so we're trying to divert the import of soya into Ireland, become more self-sufficient. So the use of field beans for animal feed is definitely something that we're looking at. And also we know that beans are a nitrogen-fixing crop, so potentially they've got benefits on the wider scale for crop rotations. His field trial treatments will be looking at different cultivations in response to different timing, different sowing dates, and different cultivars. So the first 2 treatments are what we would call conventional tillage. So we've got ploughing at different sowing spaces. Treatments 3 and 4 is reduced tillage. So they use a Claydon drill. This creates like a T shape in the soil that you put the seed in. With beans, you have to sow them quite deep because of the birds like to eat the beans. And with the treatments 3 and 4, we also have a ploughing treatment as well to represent what would be done in the UK in terms of the infestation of blackgrass. The UK has to plough to try and prevent this, whereas in Ireland we don't have blackgrass yet, so we can get away with ploughing and do more minimum tillage. He's extracting his root cause using an Eigelkamp intact soil corer. This is 5 centimetres in diameter and 30 centimetre length. This seems to be the best way to get have the minimal damage to the soil core and lets you extract out a soil core to then put straight into the CT scanner. So he'll CT scan his soil cores. This is one of the first in the grayscale image there. In terms of looking at the roots, he'll get out the information on the root architecture, the soil structure in those different cultivation treatments, and then do the root washing and the WinRhizo 2D analysis as a further data generation tool. So this is his first year, his first harvest, so he's undergoing the sampling at the moment. Two of the projects I'm going to just quickly mention are part of a CONSUS project. So this is a very large grant between Origin Enterprises and UCD. It's an SFI partnership, SFI Science Foundation Ireland, and it's really combining expertise in computer science and agricultural science to really look at how all these historic agronomic data sets these companies have and how we can data mine them to help the farmers in the field make better decisions. But there'll be more fundamental research as well in terms of the information that we're trying to get out. So David's project is looking at the effect of cultivation and tire inflation pressure on soil structure and root system architecture. So he'll be looking at the relationship between those two. Again, he'll be taking CT cores to look at root-soil interactions, seed-to-soil contact. The main thing he's looking at is establishment and potentially why in some years we get poor establishment or maybe times of the year. These are just some of the reasons why we're looking at this. We know that tillage practices can cause compaction at deeper depths and then some of the impacts this has on plant growth. So again, he's got several cultivation treatments and just in combination with the infiltration pressure as well. So again, I'm going to quickly run through this using X-ray CT to pick out porosity changes under time, root system architecture responses, and then some pore shape characteristics as well. Again, he's sampling at the moment as well. The next project is Micheál Byrne. I just thought I'd put this picture in to say that he's the Irish record holder for growing the heaviest pumpkin. His family have a pumpkin farm, so in terms of me telling him how to grow plants in the glasshouse, there's nothing I need to tell him. He's looking at biostimulants, so following on from David's project, but looking at how biostimulants is potentially an area that's like snake oil. Maybe there's a lot said about them, but really very little in terms of backing them up scientifically. So some of the biostimulants he's going to be looking at will be humic and fulvic acid, mycorrhizal fungi and endophytes. So there's some new endophytes that have been isolated in UCD in Fiona Doohan's lab, and just seeing really what the response of root system architecture is to these biostimulants. He's going to start off in the glasshouses. These are the glasshouses we have at UCD, and he's going to first of all look at the glasshouses and then move this into the field and then do some field trial experiments. Again, using the same pipeline of CT scanning with WinRhizo scanning. Stephen's project, I'll just quickly run through this, is again looking at the influence of root-to-soil interaction on the abiotic stresses of Irish cereal crops. So it's in collaboration with Teagasc, which is a government authority on in agriculture and food development. It's part of the Vicky project. I'll tell you about the Vicky project if you want to come talk to me after. It's the Virtual Irish Centre for Crop Improvement. So we have several field trials. One of them was a waterlogging trial, which was typical that it's now started in a year where we've got a drought. And this is his field trial. He's looking at oats and barley, which are two big crops in Ireland. And this is from his field trial, so it's a nitrogen response in oats that he's looking at. Just following on from Ben's talk, Connor looked at a Smartgrass project which had different functional groups, and he was taking large soil cores. These are 20 centimetres by half a metre long, and he's got the different functional groups, and we're using these as lysimeters to look at how soil porosity and different routing, maybe those niche compartments, relate to N2O emissions and how we can reduce that. This is just one of the videos of looking at soil pore architecture in a field. Potentially this creates the possibility to ground truth the variability in field with precision agriculture. Sorry, I thought I started 5 minutes behind. I'll leave this slide up. this is just one of the ways I was trying to get a CT scanner out into the field using direct radiography. This was only 2D, it's a bit of equipment that welders use. It didn't work, so potentially I think we're quite far off with taking in-field measurements of root to soil interactions, but I think we're getting there. If we use new technologies, potentially we'll get there. And I'll end now, but I thought I had an extra 5 minutes. So yeah, thank you.
Thank you, Saoirse. I think we'll take a single question.
I started at 25 past.
Notice?
I thought I started at 25 past.
Well, thanks a lot for this nice talk.